Hi everyone, my name's Tim Kington and this is Coding is for the Birds. Daisy and I are working through the process of building a Java virtual machine. We have a little bit of code working and now it's time to add some more opcodes. We also need to try some larger numbers. I think that numbers below 6 or so are being handled by special cases. And we'll see how it goes from there. So here's the program we had last time. I think if we just change these numbers to be a little larger, we're going to find that we need a new opcode or two. So let's do that. If I go ahead and try to run our program, yeah, so we hit an unknown opcode 10. That's 10 hex, by the way. So let's see what that is. That is by push. And now this one is going to take an argument. So it's pushing a byte. And the byte will be the next thing in the code itself. All right, let's try that. So this one needs to grab the next byte and use that as the argument. So we're going to go to code.opcodes PC+1, and we need to increment that. So something like this. And then we're going to push that on the stack. Let's see if this works. Okay, we got 13, 1, and 14, so that seems fine. I should mark this with the comments. This is called by push. Now, if we used a larger value that wouldn't fit into a byte, like 300, then we're probably going to run into trouble again. This is probably going to be, no, it's not right next door. Sci push, which pushes a short. So the next 2 bytes are a short. And the value of the short is byte 1 left shifted 8 or byte 2. All right. So what we're going to really want to do here, I have a feeling lots of these opcodes are going to have arguments we need to get off of the code, get out of the code. So we probably want to do this with a function. And we'd really like it to return a value and increment the program counter at the same time. This is yet another argument for using the command pattern and doing a compilation phase before our execution phase. I guess maybe it's time to do that. This is going to get fragile and ugly. And when we read a short here, we're going to have to read 2 bytes and put them together into a short. And then that's a thing we're going to want to do for lots of opcodes probably. So what we really want is a function that will read a short, but the function needs to increment the PC and return the value. Okay, so I think what we want to do here is translate our opcodes into objects that we can execute. And we'll separate that phase from our execution. Okay, so let's create an interface. I guess I'll break this up later. We're going to have a command interface or an opcode interface. We'll call it opcode, I guess. And opcode is going to be an interface, and it will have an execute that will return an int. And execute's going to take a stack And it's going to take the local variables, which right now is an array of integer. And I'm sure this is going to change and grow over time. So that's what an opcode is. We're going to need a new folder for these, probably. There are going to be a lot of them. Put this in here. And then our engine is going to have a translate function and an execute. So I guess translate could return a list of opcode. And it takes a code attribute. And really it's going to have a lot of this code. Most of the code that we had here, we're going to need to copy. So what we'll do, we're not going to create the local variable table. We're not going to need a stack. These really belong as locals in execute anyway, I think. Okay, and then it's not really program counter. What we want to do here, yes, we're going to want a new class. So this isn't going to be engine. Translator, Java. All right. This is fine. This thing is going to live in translator. Our PC is actually going to be a member of the class. So we're not going to call it PC. We'll call it index. So we're given a code attribute. There is no outer. This while is going to be while index is less than code.opcodes.length. We're going to go ahead and get the opcode. That's obnoxious. We're going to go ahead and get the opcode at index. And then we're going to translate these. So we're not going to execute them immediately, but they're going to be translated into opcodes. So we need a list of opcodes that we're building. And when we do an iconst, I think that was really a special case of another thing. So we're probably going to have a single command. Yeah, so this is just like by push I. So for iconst, we'll turn that into a by push opcode. So here we're going to add to opcodes a new by push opcode, and we'll give it the value. And this is going to be a byte. So we need a new opcode class called that. So by push opcode. That's right, it implements opcode. And then we need the execute method, and this needs a constructor, so it's going to have a private byte value, and then we need to fill that in. And in execute, we're going to return, we need to push this value. And then we're going to return, well, we'll change execute to be void for now. We don't need to get ahead of ourselves. So let's fix that. By push opcode, we can do that. What's the problem here? Really? That's because it's, sure. We'll convert the value to a byte. No, I'm sorry, we have to convert it to an int, and then the auto-boxing can happen. Yeah, that's silly. Okay. Now, translator is doing that. What's the problem here? This is an import issue. Okay, so that worked. Now, iStore might have been a special case of something too. I want these opcode classes to be the more general versions. Yeah, there's an iStore N here. Okay, so this iStore is the more general one. The one that we're handling is this one. So this is an iStore with an index, and we'll go ahead and do it that way. So we need an iStore opcode. This is going to be opcodes.add new. So new iStore code with our index. We need a new class for that. So this is going to say we need a private int for our index, and we need a constructor. And then here we're going to say local var sub index stack.pop. All right. Next up, iLoad. So we're handling the special case, but there is a case that takes an index for any local. That's exactly the opposite of iStore. Here we are loading and pushing on the stack. Okay. And then we have by push, which we already created an opcode for it. And this is the one that we were just working on, right? So we're pushing the next thing in the code. So here, this is our value. We increment index. And then here we're going to create our opcode. This is our push opcode with the value we just got out of the code. What's the matter here? Oh, it's that. This will be a byte. No, val should really be a byte here. Val should really be a byte here. And then this is the short one we were working on. We'll fix that in a minute. This is our return. I guess we need a return opcode, certainly. So let's go ahead and create that. We don't really need this right now. We're going to need it once we have functions to call, though. now, this is going to do nothing, I guess. We probably need to have this return something or throw an exception, or I guess we can make execute return maybe -1 or something. Let's make execute return an int. I think later on we're going to use this as a line number to jump to. So when we have branches and loops and things, we'll probably need that. So here I'm going to return -1 to say we're returning. I guess execute's going to need to take the program counter eventually, but for now we'll just make these return 0 if they don't want to end the program. But I think that'll probably change before too long. So our return is going to do this, and then our I add, there's no parameter or anything needed there. Actually, this code is going to go inside the new class, right? Something like this. We don't need PC++. Well, we do need index++ because we need to move on to the next byte in our code. This isn't going to happen here anymore. Our by push is already happening. We need an SI push, which was going to be case 11, right? And here we're going to need a function. This is going to be a short. We're going to want a function in the translator that will be read short. And then here we're going to say opcodes.add new SI push opcode val. So our read short will be getting 2 bytes. This will be low. Code needs to be thing, so we should probably change this stuff to be members. So we'll have code, we'll have our list probably ought to be a member. Maybe not, whatever. But we do need a constructor, I think. And we'll pass in a code attribute. Yeah, and it doesn't really make sense for, no, it doesn't matter that much. Okay, so we're reading these 2 bytes, and then we're going to return high, left shifted 8, or low, which is an int, right? Yeah. Okay, so that will read our short. Notice that we increment index once here, and then not on the second one. That's because at the end of our loop here, we're going to always increment index. So that's all right. This is a duplicate. Oh, okay. Yeah, cases don't have their own scope. Okay, so I guess this is sval. And then we need an si push opcode. And this is going to have a short value, so private short val, need a constructor. And then here we can push that. All right, translator's almost compiling. What's the matter here? It's not returning the opcodes. Okay. So I guess we have a translator. Now our engine should be given the list of opcodes now. And we're going to have a stack. I suppose we'll still be past the code attribute so that we can get things like the max locals. I guess there's probably going to be more stuff in there that we need later. PC is 0. Now this is going to change. So we're going to say while PC not equal to -1. -1 is our return. No, that's not going to work. While, actually for now, while true is still correct. We're just going to say int result equals opcodes dot get PC execute, and we give it the stack and the local vars. If we hit the return, then break. And all the code that's performing the operations now is in those opcode classes. We don't need this label anymore. Okay, what are the chances this is still going to run? I guess our code still doesn't compile. What's broken still? Oh yeah, back here, we need to use a translator. So we get our code, we're going to say translator for the code. We're going to create an engine, we're going to say engine execute, and we have to give it the code and the opcodes. We need to get the opcodes from the translator. So our code compiles. We'll see if it does anything useful. We hit an unknown opcode 2C. Is that really right? Let's see what we got. Well, that was during translate. Okay, interesting. Let's see what went wrong. I think probably my input alignment's wrong or something like that. Let's just stop when we hit this line and see what we've got. So Opcodes has only an SI push opcode in it. That doesn't seem right, does it? Oh yeah, it does. That's the first thing in the code, right? So we did an SI push, and it has a value of 4353, which isn't right, because our code said to push 300, right? That was the actual value. So our SI push case is not working right. Let's stop at this point. You know what? We're handling this wrong because the read short is using the current index, which actually points to the SI push. So I was wrong about this only needing the one increment. What we really want to do is increment it before each of these, I think. So now, what's our value? 300. Okay, so that time it worked. We do our SI push, and now we'll probably continue successfully. Okay, yes. So that fixed the other problem of the unknown opcode because we hadn't consumed the 3 values we needed to for the SI push. All right, so we're hitting 300 plus 1 is 301. That's encouraging. We should go back and make sure the old version still worked. So we can say run Java here and then run our project. And now we should see 14, 13, and 14. And if we go back to the small value that we had, then that should also still work. Okay, 3 plus 1 is 4. So this is working, but you can see that the fact that we're changing this to try the different opcodes means we need unit tests. We don't want to keep having to go in and try every case all the time. Well, that didn't really go down the path I expected it to. And this is exactly why I'm doing this series of videos. Being able to manage that complexity and adjust your design as you go is really important in a large-scale software application. So here, I just wanted to add a few opcodes, and we wound up adding in the command pattern and restructuring the way that the code executed. We put in the translator. So there were a bunch of changes needed, and that's going to let our code expand nicely as we add more opcodes and go forward. Thanks for watching. Don't forget to like and subscribe.